Hi everyone, it's Mrs. Griffin with the Unit 5 Lesson 10 video about similarity transformations. So similarity transformations are going to exist if we have two figures that are similar, and we'll know that they're similar if there's a sequence of rigid motions and dilations that maps one to the other. Okay, so if we can say that there's rigid motions plus dilation, then we'll know the figures are similar instead of congruent. We also have these three words that are interesting to know. Reflexive, we've talked about how something is congruent to itself, but similarity is also reflexive because a figure is similar to itself. It means that it has a scale factor of 1 when that happens. Similarity is transitive, which is kind of like substitution, meaning if two figures are similar to the same figure, then they're also similar to each other. Okay, and then it's symmetric because if you know one figure is similar to a second, then you could say that it works backwards too. So if you can map an image to a pre-image, then you can go backwards and take that pre-image back to its image as well. So we say that there are inverse transformations. To map it back. Okay, and an inverse transformation is a series of transformations that will map an image back to its pre-image. So it undoes a transformation. That's what an inverse does. So for example, if we were translating along a vector that would start at A and end at B, the inverse would be to also do a translation, but starting at B, ending at A. If we were reflecting over the line XY, then we would reflect back over the line segment XY. It would be reflected back over the same thing. If we're reflecting over a line that has an actual equation, then we would still reflect back over that same line. So to undo a reflection, you would reflect back over the same line. If you were to rotate 45 degrees, then the inverse would be to go backwards 45 degrees, or you could also complete the 360. So another 315 degrees would be able to map that image back onto its original. Same thing here. If it was a negative 100, then a positive 100 would take it back to itself, or a negative 260 would complete the 360. If you were dilating something by multiplying it by 2, multiplying that thing by 1/2 would bring it back to itself. If you were dilating it by 1/4, making it smaller, then dilating it by 4 would map it back to itself. So as a general rule, if you have a number for your dilation, its reciprocal is the inverse, making sure that you flip if that was a fraction. So multiplying by 2/3, the inverse would be to multiply by 3/2. Another one that we should add in here is a translation with numbers. So if we were going like 4, -2, the transformation's inverse would be to go left 4 and up 2. You just negate both. Okay, so we have an image and a pre-image, and we're going to identify the similarity transformation that will map one to the other. Starting with the pre-image, the one without the primes, we want to map it to become the image. So with a transformation on the coordinate plane, that's pretty simple because we can do a lot of counting and exact numbers. So if I wanted V to move to V prime, the first thing I would probably do is translate it. And I would move right 9 and up 7. Right 9, up 7. Then, if I did that with the other ones, 1, 2, 3, 1, 2, 3, 1, 2, 3, I would be here and here. Okay, and then I would want to dilate it. So remember with a dilation, you want to tell me the center of dilation, which in this case is V, or the origin. You could use either letter. And the scale factor, all you have to do is take one of your names from your image, like for example, V prime, U prime, and put it over the matching from the original, VU. Because you're basically saying, if I were to divide the length of V prime, U prime by VU, then I would get my number for my scale factor, whatever it might be. If you have numbers that are easy to count, like we happen to have here, you can see that this was 10 and this was 6. So you could say 10 divided by 6, and that can be your scale factor instead. So you can use the name or you can use the numbers. Okay, so if I wanted it as function notation, I would make sure to put the dilation first, because with these work right to left, and then put your pre-image in the parentheses. Either way is acceptable. You can also write it out in words. So for number 11, if we want z to move to z prime, we have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right and down 7. And if you want to use it in words, you can. And then we have to figure out our dilation. Then we would be dilating it centered at z prime, scale factor, and you can count. So from here to here, the number of units would be 1, 2, 3, 4, 5, 6, 7. And here it would be 3. It's a good easy one to count. So 7/3, image over pre-image. For number 12, there's a bunch of ways we could do that. You can translate first, reflect first, or dilate first. It's up to you entirely. What a lot of students like to do is reflect it first, so at least it's facing the same way. So if we start with triangle ABC and we reflect it, for example, over this, and since I don't have any actual axes, I'm just going to call it line L. If I do that, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, I'll get this triangle. And then you can translate that triangle up to 3 units. And if you did that, you would be here, here, and here. And then you can do your dilation. So the first thing I did was this reflection. The second thing I did was to translate it, and then I can do a dilation. If I were to write that out in words, I would say that I reflected triangle ABC over line L. And that can be step 1, or you can do it as a whole sentence. Step 2 would be to translate up 3. And then the third thing I'm going to do is my dilation. Now remember, you need a center and a number. So we're going to dilate centered at A prime by, and then you're going to count something simple. So I'm going to use the horizontal again. So for the original, AB was 1, 2, 3, 4, 5, 6, 7. And the new one is 14. So you can see I doubled it. So dilate by 2. Okay, for number 13, there's definitely a rotation in there, so you can do the rotation first if you'd like. If you want to, you can rotate around the origin. If you want to rotate around point B, that's fine too. But I'm definitely going to start by rotating. A lot of people prefer to rotate around the origin. And since we're going clockwise, we're going to do negative 90 degrees. And if I did that, remember, you can turn your paper 90 degrees. Triangle ABC would now be here. And interestingly enough, if you were to count from your center of 0, 0, up 1 over 1, up 1 over 1, the scale factor is 2. And the same thing for this one here, up 1, 2 over 1.5, up 2 over 1.5. You'll see that your scale factor actually is just 2. You can also measure that this is 2 and this is 4 like we did on the other one. So if you use your center of dilation as the origin, you can just say R equals 2 for your scale factor, then you can get it that way too. Okay, number 14, if I were to try to do this, I would have to rotate first. You can dilate first if you want. And this one, because everything's all connected by straight lines, would clearly be 180 degrees. A would move here and B would move here. And then we would need to dilate from C. And you can see that 5 to 10, our scale factor is 2. Okay, for 15, a little bit different. I'm going to rotate it first again. I'm going to do it a little bit differently than some of the other times that I've rotated. I'm going to rotate around C, so AB becomes parallel to A prime, B prime. And what that would do is it would turn it, so A would be down here, B would be down here, and it would match up with that better. Then I can translate it so that C moves to C prime, and if I did that it would be here, and then I can dilate it and it would be centered at C prime because now I'm over here, and it goes from 3 to 5, so my scale factor is image over pre-image, 5/3. Okay, on this one it's a little bit easier because I can actually construct my center of rotation because the lines are parallel right now. So if I go from A to A prime and beyond, B to B prime and beyond, I can find my center of rotation as actually, or center of dilation rather, is actually right here, and that one's a lot easier. So I can just say dilate from O and do my scale factor with the letters. A prime, B prime over AB. And I can do the same thing on 17. I can construct my center of dilation, A to A prime and beyond, C to C prime and beyond. If you want to do B to B prime also, you can. And same thing, give it a letter. Oh, P, let's use P this time. And show that this one's just a dilation centered at P. And your scale factor, image over pre-image, would be 5 over 8, because image is the one with the primes. It's 5/8 of its original. Okay, for 18, lots of ways that we can do this. You basically need to figure out how much is going on here. The first thing I notice is if I'm labeling A, B, C, D, E, that's counterclockwise labeling. A, B, C, D, E with the primes is clockwise. So there's definitely been a reflection. Anytime that switches, there's been a line reflection. So I might try to reflect it over one of its sides. Like if I reflected over CB, I would get this. Okay, then maybe I would try to translate it so that B would map to B triple prime. So when I did that, it would go here, and if these were parallel, it would be here, 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 and here, and I'd get my D double, E double, and A double primes. Okay, and if I wasn't sure they were parallel, I could add in a rotation to say that I needed them to guarantee they were parallel. I think they are here, but if I wasn't sure, I could say rotate around B triple prime, so DE with the doubles over here is parallel to D triple prime, E triple prime. That way I'm saying it definitely has to be parallel. And then once I have that in there, I could do my dilation from B prime, triple prime, using the scale factor, and then just do a final image, like for example, pick a side D triple prime, E triple prime, and put it over its original one, DE. Okay, same thing here. There's clearly been a reflection. So what if I reflected so that triangle AB prime C is like that now? And then maybe I would want to rotate it so that AC is parallel. So that would look like this. And then I could do a translation so that it was over here. And then a dilation. And then I could list them out like this. All right. The key is that I have to be able to replicate what you're doing with exact letters. So make sure that you're either labeling as you go or using letters and spots that already have names, like when you reflect over something that's already a line that's there. Okay. And there are so many correct answers to each one of these that I'm not going to tell you one way is better than the next. What a lot of people will try to do first translate, then rotate, then reflect, and then dilate. And if that helps you, you can do it that way, but it's really all about whatever you see in a particular picture. See you in class.